Hi, this is Chong Kim. Welcome to Tic Tac Toe 4x4 in Java. Okay, so we're going to start off by writing 3x3 first and then convert that into a 4x4. Alright, so let's begin. So first thing we'll do is we'll create a project. We'll call it TTT 4x4. Create a class called position, and we'll write our test. So test. Okay, and if we run this right now, we have a failing test because this is set to fail. All right, so we'll make a real test now. So we're going to create a test for the constructor, so new position. So if we have a position and we expect that it'll be x's turn, so position's turn is going to be x, and that 1, 2, 3, 1, 2, 3, 1, 2, 3, and that the board will look like this. Actually, we just say toString. Okay, so first thing is it doesn't know anything about turns, so we'll just create that, and that will be a character. Okay, so now, so you can see that here the error is not yet implemented. So if I run it now, we have an assertion error that says that it was expecting some value but got a 0 because it was not initialized. So we need to create a constructor that will set it. So we'll set the constructor so that the turn is x, and so we should see a different error now. It says expected some string but got something else. So we need to override the toString function. Okay, and we need a way to represent the board. So we'll create a character array called board, and we'll set it over here. So board is equal to new character array, and depending on the size. So we haven't set the size yet, so we'll set this to be public, and it's dimension times dimension. But we haven't specified dimension yet, and that would be public, and we'll say it's 3. And if we do everything right, then we should be able to just turn this into a 4, and we have a 4x4 tic-tac-toe program. All right, so for the string, what we'll do is we'll take the board. Actually, we'll create a string out of that board. All right, and now if we run this, it should pass. It didn't because we didn't initialize it, so we have to go here. Okay, and we'll just say size. Okay, we'll set it all to be empty spaces. Okay, so now it passes. So the next step is move. So that should be move. And so we start off with a position, and we make a move. So move 1. Okay, so let's create a position, and I'll just call it IDX. Okay, so what we'll do is, and this will return itself. So what we'll do is we'll take the board's index position and we set it to be whoever's turn it is, and we have to switch turns. So turn is equal to, if it is X, then we want it to be O. Otherwise, it'll be X. Okay, so let's go back to the test. We should have actually started with a failing test, but instead we made this pass. So for now, I'll just comment this out just so that we can have it fail. Okay, so it should be O's turn. So okay, and it should look like X. 1, 2, 3, 1, 2, 3. All right, so we should see that this fails, and now we uncomment this, and we should see that this passes. All right, so we should have possible moves. Actually, One other thing that we need to do is unmove. So actually, let's just do unmove here. Okay, and the way that works is actually it should look just like the initial position. Okay. And when we do a move, and then we do an unmove of that same thing. So these are inverse operations. Okay, so let's see. Oops. Unmove. And we need to create the unmove. So unmove. Okay, so the way the unmove will work is, oops. At that position, we're going to just put a space there. Oops, space. And the turn is just going to be the same. Okay, and then we're going to return this. Okay, so it works very similar, except we put a space back. Okay. All right, so this should pass. Okay. Again, I should have had a failing test. Okay, so all right, so we have move, unmove, possible moves. So okay, so we have to create a list. Unfortunately, Java doesn't have a mechanism to create a list on the fly, so you have to create a list this way. So it's a list of integers and new array list, and we're going to go through actually it's from position size. Okay, see list, we're going to add those integers, and then we're just going to remove those ones that we don't want. And okay, so we can figure this out from here. So we have a new position, and we make a move 1 and move 2, and we see possible moves. Okay, and when we do, okay, so let's just, okay, create method, and creates a list of integers. Okay, doesn't know about lists, so we'll, okay. All right, so let's see, so we get the possible moves. So that should be, we need to remove 1 and 2 from it, but we can't just do it like this, because when we say 1, that means it's at the index position 1. So we actually want to remove that object, so we have to say new integer. It's because if you put an object here, then it'll look for the value. Otherwise, if it's an integer, it'll think that it's the index. Okay, so it's basically all the values except for 1 and 2. So if we made a move 1, 2, that's what it should be, and this should fail, so we can make it real now. So we start off with a list of integers, list, okay, and we're going to go through and iterate over the array, the board, and okay, so we have a condition. If the board at that position is a space, then we're going to add it. So list add I, and then we're just going to return the list. Okay, so I expect this to pass. It does. Next, win4 is win4. Okay, so we have the let's see. Okay, let's have a sanity check. So if we have a new position and we say is win4 X, this should be false. So let's create this. So Boolean turn, and we'll just say it's false. Okay. Next is we assert it's true if we have a new position that looks like 2, 3, 1, 2, 3, 1, 2, 3. X's turn. We say is win for X. This should be true. Okay, so this is okay. It doesn't know about this constructor, so let's create this constructor. All right. Okay. Right. So the board is going to be the string, and then we need to convert that into a character array. Turn. Okay. Actually, I want to call this turn and just say this board and this turn. Okay, it reads a little bit better this way. Okay. All right, let's go back to the test, and this should be a failing test. It is, and we need to fix is win for. So we need to go across. Actually, we need to go down for each of the rows. So, and instead of size, it is size. And in increments of the dimension. Right, so that means that it's going to start off 1 and then go to the 3 and then to the 6. Oh, and we need to have a variable here, is win. Okay, so is win, or okay, so we have a line match based on the turn. And the starting position is going to be I. The ending position is going to be I plus the dimension in steps of 1 because it's going across. Okay, so we need to create line match. All right, so line match. Okay, so that's the turn. That's the starting point. That's the end. And that is the step. Okay, so, and if everything goes well, then we'll say it's true because we're going to look for something that is not equal to the turn. Then we know that we can return false. So, okay, start, end, and plus equals the step. Okay, if the board at that position it doesn't equal whatever you're looking for, then return false. Okay, so that logic seems correct. Okay, it's let's see. Oh, the reason why is because I'm is win for is always returning false, so is win should return that variable. Okay, it passes. Okay, so we have it going across. Now we need to have it go down. So to make this a little bit easier to read, I'm just going to split this up, 2, 3. Okay, and then line this up. And so this way, it'll look like that. Okay, so let's see. Okay, fails. So we need to create a new one. And the increments this time, oh, we do actually want to go across, but we don't want to go all the way through. We just want to do the top layer. The reason is because we're going down. So is when, okay, so now we have to think about how the line match works. Okay, the starting position is going to be I. The ending position, we'll just say is size because we want it to go all the way to the end. And in increments of the dimension. Okay, all right, so each row, right? All right, so this should pass, and it does, great. Okay, so we'll take this code and make it go diagonal. This time we'll use O's. Right. All right. It doesn't matter whose turn it is. We're just looking for those characters. All right. So this should fail. And this time we don't need a for loop because we're just looking for one line, which is the diagonal. So we can just write it here. Line match. Okay, the starting point is 0, ending point is all the way to the end, and instead of dimension, it's dimension plus 1 because that makes it go diagonal. Okay, that passes, and we make another copy of this. And this time, make it go in the other direction. All right, and this should fail. So we go back here, and all right, so now we have to think about the starting point. The starting point is going to be dimension minus 1. So that's the upper right-hand corner. In steps of dimension minus 1 because it's going in that diagonal. But we have to be careful because this would also include the lower right-hand corner. So we have to remove that. Okay, great. So we're done with is win4, so we can start working on the minimax. Okay, so minimax. All right. So the first thing is a win for x. So let's see. Okay, so let's see. It'll look like xxx 1 2 3 1 2 3, and x's turn. Okay, so all right. So what it's going to do is it's going to return how many blank spaces there are. Okay, so first let's create the minimax. It returns an int, and it returns, well, let's just say 999. This should be a failing test. Oops, we didn't save this. Okay, so let's run this. Let's see what the problem is. Minimax, but we did create it. There's the minimax. Okay. Okay, now it realizes that it's there. All right, so let's say if is a win for x, then return how many blanks there are. And we have to specify that. So public in blanks. Okay. Okay, we have to loop through. And we have to put an if condition here. So actually we don't want to say, is it size? Yes, size. Okay, so we look at the position, and if it is a blank, then we increment the total. Okay, and then we just return the total. All right, so that should be how many blanks there are. All right, so this should pass. Great. All right, next is a win for, if it's a win for O, we want it to be a negative value. This way, okay, so this way they would conflict. One would try one would try to make the max of it, and O would try to make the min of it. Okay, so we do the same thing here, except we look for the O, and this time we return negative blanks. Okay. All right. There's another condition where we expect it to be 0 if everything is completely blocked. So if it is XOX, XOX, OXO, that would be completely blocked, and this should fail. So we can count the blanks. If that is equal to 0, then return 0. Okay. Okay, and we want to also make sure that the recursive case also happens. So this way, if you're off by 1, that it still gets the same value, because if it's x's turn, it can put an x here and it'll be 6. So eventually it'll end up as 6. So let's just check those out. And so we have to handle the recursive case. So okay, so the iterable, we're going through integers. And the iterable is possible moves. All right. Okay, so actually we should make a list of integers. All right, and we're going to see, we're going to make the move and find the minimax of it. But after we do that, we want to unmove it so we can bring it back to the way it was. Okay, and when we're done, we're just going to say there's a collections, and we can say max of that list. Okay, so it'll return the max. All right, let me see. All right, so if we run this, it should fail, but let's see where it failed. This meant that the first one passed, so now we have to handle the O case. In the case of O, we put this as two parts. The first part is for the x, so if return, just leave it like this and see. If it's x, we want to find the max, otherwise we want to find the min. Okay, we run this and everything passes. Okay, so this one takes 41 milliseconds, and what we're going to do is we're going to make this a little bit faster by caching it, because for a 3x3 it's not so bad, but when it gets to a 4x4 it's going to get pretty bad, so we want to have some caching in here. Okay, so what we're going to do is at the very top here, we'll just make this private because no one needs to know about this. Let's see, it's going to be a map. The key, to make things faster, let's just have an integer representation of the board, and it's going to also store the integer, and we'll call this cache. Okay, and let's store it as a hash map. Okay. Oh, new hash map. All right. So that creates the cache that we can use. Okay. So actually, let's write a little test for this. So if we have the initial position, let's just have the initial position, then the minimax of this should be 0. So if we run this right now, this will take quite a bit of time. So let's see how long this takes. Oh, this passed right away. Let's figure this out. It was pretty fast, but instead of, I think it was about, was it 20 or 40 milliseconds? And now you see a big jump. Relatively, it's a fairly big jump. If it was a bit bigger, if it was a 4x4, this number would have been very, very big. Okay, so that's what we're working with, 174 milliseconds. Let me just do this again. 170. Okay. All right. So let's put the caching in here and see what this turns out to be. So first we'll need a key. So integer key is equal to code, and let's specify what the code should look like. Okay. So since there are public. Okay, so since there are three possibilities, it can either be a blank X or an O. We could have a number based on 3. So int value, start off with 0 and go through the see, okay, so and return value. Okay, so okay, if see, okay, if it's a space, we'll choose space as a 0. If it's an X, then it'll be a when, so value is a 1. Else, if it's an O, then it's a 2. Okay. And the next time around, we have to shift it over by shift it over, so we can say value is equal to value times 3. Okay. I could have used, because this is a map, I could have used the string representation to store it, but allocating and deallocating strings would probably slow things down a lot. So this way I'm just using integers, so it saves memory. And this will probably be faster too. Okay, so we have the key, and from the cache, we're going to get the key, and that's the value. Okay, so if the value is not null, then we can just return it. So everything is good. And otherwise, we'll go through this whole thing and we'll end up with some value. So value is this, and we're going to return the value. But before we return the value, we are going to store it back in the cache. So cache.put key value. Okay, so this should, okay, so there was 3 steps. One is creating the array, creating the map, which we did at the very top. Then we checked for the value, and then we set the value. Okay, so if you run this now, it was 167 milliseconds. So we made it about twice as fast. But this is misleading because you think this is twice as fast, but because you're cutting off calculations that you wouldn't have done, when it goes to a 4x4, this will make a dramatic difference because it's not just twice as much. You're cutting off lines of searching. So this should make it a lot faster. Okay, so let's take a look. Okay, so minimax is now complete. And let's see, we need to find the best move. All right. Okay, so we expect, okay, let's put the position 2. So new position, okay, XX, 1, 1, 2, 3, 1, 2, 3, okay. And it's X's turn. This time the turn is important because it's going to make that move. Best move, it should be 2. Okay, so let's just create a dummy version of this. Int, and returns, let's say, 0. Okay, so if we run this, it should fail. Okay, so let's think about how the best move it should work. So we have the possible moves, and we want to find the max of that. So there is a, let's see, let's look at collections again, and there is a max, but there's a max that takes a comparator. So the collection is possible moves. Let's just store that in a variable. So list of integers, list is equal to possible moves. Okay, and we'll just use list over here. Okay, and actually we're just going to return this. Okay, this is only for the max part. So the comparator, actually let's just say CMP, and we'll define the CMP here. So comparator, and comparator which takes an integer. So it's going to compare two integers together. CMP. All right. New comparator, and we need to add the unimplemented function, which is compare. All right. So it returns an integer. So let's just say first and second. Okay. Okay, so for the first value, the integer that's coming in is the index position, but what we want to end up is an integer that represents the minimax value, because that's how we're going to sort it. We're going to sort it based on minimax. So this is the first index, and let's do that. So we make a move based on the first index, and then we're going to find the minimax of it. Okay, and we need to remember to unmove on that. Okay. Okay, the second one, I'm going to find the minimax of that and unmove the second one. So now we have A and we have B, and then we're just going to return A minus B, because that's what CMP is supposed to do, is takes A and then minus B. Okay, so that should handle that, and I expect this to pass. Okay, great. So hope you got that part. All right, so now we're gonna have the O version of this, and if we just leave it alone, it's not going to pass because we're using max. So we need to conditionally say, we can leave this alone, and over here we say depending on whose turn it is. So if the turn is X, then we want it to be using the max. Otherwise, we're going to use the min, list, and CMP. Okay, so this should pass. Okay, so we have minimax, best move, and the last thing we need to do for this is game end. So how do we know if the game is over? Let's see, this is a Boolean. So start out with something false, which is a new position. Is game end should be false. Say that one doesn't exist, we'll create it, and it just returns false. That should pass. Okay, so let's make a true version. Okay, so we'll create a position where X wins. 2, 3, 1, 2, 3. Okay, and we say is game end, and this should fail, so we put that test there. Is win for X. All right. And the other situation is if it's O. Okay, we need to put that in there as well. So we say or is win for O. Okay. And okay. Okay, so now what about if it's completely blocked? All right, so we say okay, if there's no more blanks. Okay, so we have everything. I think position is now completely set up. We have our test and we have our code. So we can start creating the user interface for this. Okay, so let's create a new class called game, and okay, we're gonna have a main there. Okay, and just to make sure that everything is set up, we're just gonna put like a hello and see if that works. So if I, okay, we see hello over here, so everything is working. All right, so first thing is we're going to say that this extends JFrame. Okay, so this is going to be the window. Okay, and actually we need to import that. And in the main, let's see, there's swing utilities dot invoke later, and this takes a runnable, so new runnable. Okay, so we need to overwrite run, and this part is going to be really simple. We're just going to create a new game. Okay, and that's all we do. And if we run this right now, we see that there's a game, nothing's happening, and it just exited immediately. So okay, so what we're going to do is create all the things that we need in the constructor. So we're going to say, here's the constructor, and we're going to set the, let's see, set the layout, okay, to be the grid layout. And grid layout can take rows and columns. So this is going to take the positions dimension. Okay, so dimension by dimension. So it's going to be a 3 by 3. All right. And pack, make sure that all the elements are realized. And let's see, one other thing that needs to do, I think, is set, let's see, show. Let's see, just see what happens if I do this. Nothing. But okay, and then okay. Let's see, what is it? Thought it was like set something. Set locale, opacity doesn't sound familiar. Oh, set visible. That's what I want. Okay, true. Oh, all right. So at least we have a little window over here. So okay, we can quit this now. All right. So let's put something in this grid. Okay, so depending on the position size, we're going to put that many buttons. So let's say create buttons. Okay, and this one doesn't exist, so let's create it. And we're just going to create one button in here, but it'll create that 9 buttons. So let's see, it's a J button. We're going to create a new button, and we're going to specify a size to this. I think preferred size, and it takes a dimension. So new dimension, and I think here it takes a width and height. So let's just say 100 by 100. Okay. Okay. This just creates the button, but we have to put the button in the frame. So we can say, I think it's add. Yeah, add button. All right, so now I run, and we have these buttons, which is 100 by 100. Okay, great. Let's set the background color for these buttons, the space in between, to black. Set background color to be, I think, color black. And we also have, if we just do this alone, it's not going to do anything. We have to set the opacity to be, set opaque, I mean, to be true. Okay, so now, okay, now it's black underneath. So when I click on this, I want it to put an X. So, let's see, we'll do it over here. So let's just actually, instead of returning void, I'm just going to return JButton over here. Button. Okay. Okay, so actually it should be called that. It should be called buttons. Create button because it's on creating one. All right. So add mouse listener. So I need to create a mouse listener, so on the clicks I want it to do stuff. But instead of creating a mouse listener, I'm going to create a mouse adapter. This is the same thing as mouse listener, except that instead of an interface, this is a class, and it dummies out all the methods. So this way, I can concentrate on the thing that I want, which is mouse clicked. Okay. So when you click it, I'm going to set the button. So the button set text to be X. Let's see if this works. There's a problem with this. It's saying that refers to a non-final, so let's just make this final, which means I'm not going to be changing the binding for this. Okay, so if I run this, if I click on it, I have a little X. So let's just let's fix the font. Okay, so create button, set font, new font. Okay, so attributes. Okay, so string. The name we'll just, I don't know, style, font, plain, and the size. Let's say 20. I don't know if this. Okay, let's see how 20 looks. No, let's make it 50. Okay, 50 is a lot better. All right, so all right. So instead of okay, actually we need to create the position. Okay, so okay, so now we have a position. We can say let's see, the turn. Now we have to wrap this in a character to string because this is a character and set text is expecting a string, so we need to convert it. Let's see, there's an error. What is the error? Oh, too many. Okay, there was too many parentheses. Okay, so so after it prints it, we'll actually make the move. So position move on I, or index. So whatever the index happens to be. Now I here is an integer and I keeps on changing, so you can't have that. So instead I'll have a variable here, idx, which we'll store, and the difference is that this idx, this integer, is final. All right. So now we should see a change. Okay, great. All right, so now we have to make the computer play. So if not, if not position is game end. Okay, so if it's not the end of the game, okay, we want the computer to make the move. So oh, actually, all right. So we need to have an array of buttons because it's going to return an integer, and so we need to store the buttons as an array. So okay, and the size of it is going to be based on the position. So position size. All right. So and we store it. So here's so we'll say see. Actually, we'll just keep it like this, and then buttons. Okay, we store it. Okay, so okay, so let's find out what the best move is. So position dot best move, and we need to update the string. So buttons. Okay, so we find the best moves button, and we're going to set the text, not set action, set the text to be character to string of position turn. Okay, I'm going to get rid of all of this stuff. Okay, and then we need to update the position. So position move the best move. Okay, so let's see if this works. Computer's playing. It's good. Let's see if it wins. Hey, it won. Okay, in this case, I'm still able to play, so we need to say if the game has ended. So if position is game end, then we want that little dialog to pop up. So okay, we have the message, and if is win for X, then you want to say you won, which shouldn't happen. Okay, is win for X, O, that's the computer, so computer won. Otherwise, it's going to be a draw. So those are a situation. All right, so we have the message, and we need to pop that up with a J option pane. I think it's J option pane. Show message dialog. Okay, so the parent, we'll just say null, so it'll do the root, and we have the message. So let's see if this works. So if I click, and there's a message saying that the computer won. Okay, so this is working right now. So let's see what happens. Now, if I did everything correctly, actually there's a warning over here. I don't like warnings. So let's see what the warning says. Add default serial version ID. So let's just do that. Okay, let's get rid of this. Okay, so we have no warnings. Okay, we run it and everything is working fine. Block. Okay, and this should be a draw. So there it is, draw. Okay, so let's see what happens if we turn that. Okay, let's go all the way here, and we change this 3 into a 4, because so far everything that we've done was general. So I changed that to a 4, and let's run it. Okay, so now it's a 4 by 4. All right, so I click on this. Now this is going to take a little bit of time for it to calculate. Okay, so that took a few seconds, and let's see if I'm gonna play dumb, so I'm gonna see if it wins. Oh, actually, okay. Okay, I'm gonna click on this, and the computer should win. All right. So let's try this again. This is a very different game, but you can see that it is thinking. It takes about 20 seconds to make this move. Okay, so I think that it knows that there's no way that it can force a win, so it is not making the best moves. Yeah, this is going to be a draw. So, okay. So if this hadn't worked, and let's say that there was an error here somewhere, like let's say that I hard-coded a, let me see, let's take a look at one of these things, like this dimension over here. Let's say that I hard-coded a 3 here instead. So if I run this, let's see, not sure how this is going to work. Well, it's still playing okay, even though, yeah. Okay. Let's see. Trying to make this break. Maybe is win for, let's see. Okay, so let's say, for example, well, it's kind of hard to find a good place that will show the error. Okay, so what I would do here, let's say that I did find an error, is let's see how this test works. So I run the test and it fails. So what I would do is I would just go through and modify these. So 1, 2, 3, 4 now. Okay. 1, 2, 3, and okay. So this is new position, and new position is right here, and it's failing. So new position is now passing. So let's test move is failing. So see 1, 2. Okay, so let's line this up a little bit. Okay, so test move, move. Okay, it's passing. It's passing right here. Test unmove. Okay, so let's see. 1, 2, 3, 1, 2, 1, 2, 3, 4, 2, 3, 4, 2, 3, 4. Okay, test unmove is now passing. Possible moves. Let's see possible moves. Possible moves is already passing, so we could skip that. Test is win 4. It's right here. And let's make this pass. So it should be 4 X's and 1, 2, 3, 4. Okay, line this up. Okay, so that one should pass. We just put some extra spaces in there. Oops. Okay, make a copy of this. Okay, and this one, make a copy and just put some spaces. Oops. All right, and this one, same deal. Okay, so now is win 4 should pass. Okay, the minimax, let's see, it should be a win for x. 1, 2, 3, 4. Okay, and this is for O. Okay, and actually the values aren't correct because now it's 12. So you have 12 empty spaces, so these should be 12. And for something that's completely blocked, and it just should be too hard to come up with a blocked position. Oh, no here and put an X there. Okay, and one more, so X, X, O, X. Okay, so this is completely blocked. Oh, actually, make that an O. Doesn't really matter. Okay. And for this, we'll just use the same situation. Oops. Same as this. Just copy that. Except that we'll take one out. Okay. And a new position. Okay, now this should be interesting. Let's see how long this one takes. So run. Okay, it's 5 out of 8. It's working on minimax. So it's taking a bit of time, which is good news because that means that all of these things passed, and it's working on this one, which is kind of slow. Okay, so that took about 20 seconds. Let's see what happens if we make a move. So move 1. Okay, so remember it was 20 seconds, and if we run it now, it's about 5 seconds. So you can see that every time there's an empty space, it makes a jump by some factor. Okay, so let's continue. So minimax. So even if you had made that move, it's still a draw. So everything. So it's hard to win in a 4x4. So okay, so the next one is game end, or best move. Okay, for the best move, it is position 2. So let's just keep it at position 2. So let's go like this, and 2, 3, 4, 2, 3, 4. 2, 3. Okay, line this up, and put an O there. All right, so let's see if that passes. Okay, the minimax is still taking a bit of time. So this is kind of interesting because it takes like about 6 seconds. So minimax, let's make one more move. So move 2 dot minimax, and let's see how quickly that becomes. Remember, it's 6 seconds. We run it, and it happens pretty. Okay, it's about 2 seconds. Okay. Okay, so let's see, test game end. So game end, we need to update this. So 2, 3, 4. Okay. And do the same thing for this. And assert true game end when everything is blocked. So let's see if this is blocked. All right, let's line this up and make sure it's blocked. So put an O, X, O, and X, O, O, O. Okay, so that looks blocked. Okay, so everything passed. So if we had found a flaw in the game that it wasn't working the way we were expecting, then what I would do is just convert the tests, make sure that the test is converted, and all of these functions work the way they're supposed to, and you end up with a 4x4 tic-tac-toe with very minimal changes. So this is tic-tac-toe 4x4 in Java.